In this video, we are going to look at the first derivative test, which is basically going to help us decide where things are increasing and decreasing, and if a critical number is a maximum or a minimum. So what the first derivative test will tell you is if you take the derivative, and this is in your packet, and the derivative is changing from negative to positive at c. So here's your critical number c. And the derivative to the left of c is negative, as you can see. And the derivative to the right of it is positive. So it's going from negative to positive. And this makes total logical sense. Then this point right here is going to be a minimum. Negative to positive. Okay? If the derivative, in this case, is going from positive, here the derivative is positive, here the derivative is negative. So this critical point right here, c, is going to be a relative maximum. If you have something that isn't changing, so the derivative here is positive, the derivative here is positive. So this number right here is neither a relative max or min. Okay, this is not a critical number and it's not a max or min. Okay, same thing here. The derivative is negative here, the derivative is negative here. This point right here is neither a max or a relative max or a min. Okay, so we're going to use this information to make some decisions and about certain functions and figure out if they're where their relative extremas are. Okay, so here's an example. It's got some trig in it, and I love that. So we are going to, first of all, we're going to do something very similar to what we just did in the previous video. First, we're going to find the derivative and find our critical numbers. Okay, so the derivative of this function is 1/2 minus the cosine of x. Okay, that is the derivative. Then we're going to set this equal to 0 because we have to find our critical numbers. So we subtract 1/2 from both sides. So we need to know where cosine is 1/2, okay, in this interval between 0 and 2 pi. So to check your unit circle, you're going to see that x is going to be either pi over 3 or 5 pi over 3, because cosine of pi over 3 is 1/2 and cosine of 5 pi over 3 is 1/2. Okay, so those are our critical numbers. So now we're going to put our intervals in here. So this interval is going to be from, well, we're just going from 0. So we're going from 0 to pi over 3. Then we're going to be from pi over 3 to 5 pi over 3. And then we're going to be from 5 pi over 3 to 2 pi, because we were restricted in the interval between 0 and 2 pi in the first period. So we're going to test some values. We're going to pick some values just like we did before. So let's pick pi over 4 because we know the 45-degree triangles, okay? And we're going to pick pi because that's in between pi over 3 and 5 pi over 3. And then we're going to pick 7 pi over 4. That's another 45-degree angle. So pick values that are going to be easy to calculate. Now we have to figure out the signs of the derivative at each of these points. So you're going to take pi over 4 and you're going to plug it into our derivative, which, let's go back up here. Here's our derivative right here. Okay, so the cosine of pi over 4 happens to be radical 2 over 2. If you do 1/2 minus a radical 2 over 2, you are going to get a negative number. So this is negative. Okay, if you find the cosine of pi, okay, the cosine of pi is 0. So 1/2 minus 0 is going to give you a positive number. And then same thing here. If you get the cosine of 7 pi over 4, it's going to be radical 2 over 2. So this is going to be a negative number. So our conclusions are, we have something that is decreasing here, okay, increasing, function's increasing, and then the function is decreasing again. Okay, so let's think about this. I'm going to actually, I think it's really easy to figure this out, okay? So I'm going to add, what color? Oh, let's do red. So as you can tell, the function is decreasing and then it starts to increase. So at pi over 3, that value right there has to be a minimum. Then it increases and decreases, okay? So this value here, 5 pi over 3, has to be a relative maximum. So our relative minimum is pi over 3. Our relative maximum is 5 pi over 3. And then to find the actual y-coordinate that goes with these, okay, you would have to plug pi over 3 into your original equation. And when you do that, I'm not going to spend time here doing all that algebra, but you would get pi over 6 minus radical 3 over 2. And here, if you plug in 5 pi over 3 into your original equation, you would get your y value, and it is 5 pi over 6 plus radical 3 over 2. Okay, so this is your relative min, and this is your relative max. Okay? So now I want you to give this a try. Okay? Here is the function. You're first going to find the derivative. Then you're going to set the derivative equal to 0 to find the critical numbers. Then you're going to put your intervals here around your below and above and in between your critical numbers. You're going to create some test values. You're going to figure out your sign of the derivative at those test values, and then you're going to draw your conclusions about where your function is increasing and where your function is decreasing, and that will tell you where these if these critical points are max or relative mins. Okay, let's see how you did. First of all, you have to find the derivative of this. So the derivative of this function is, if you use the chain rule, so you get 2/3 times x squared minus 4 times the derivative of the inside, this is the chain rule, 2x. So when you simplify that, you end up getting, I'm sorry, I forgot my x to the negative 1/3 right there. When you simplify this, you end up getting 4x divided by 3 times the cube root of x squared minus 4. Now remember, we have to set that equal to 0 to find our critical numbers. So our critical numbers are going to be where our slope is 0. So here, our critical number is going to be x equals 0, because if x is 0, our slope is going to be 0, and that's a horizontal slope, and that is a critical number. Now remember, the other place you can have a critical number is is where the derivative is undefined. So the derivative is going to be undefined when this denominator is 0. Okay? So if x is 2, or if x is negative 2, that's going to make this denominator 0. So these are our critical points. Okay? So we're going to put these critical points into, we're going to put the intervals in between our critical points. So here is negative infinity to negative 2. Okay? Then we have negative 2 to 0, 0 to 2, and then greater than 2. Okay? So there's our intervals. Pick some test values. Let's do x equals negative 3, x equals negative 1, x equals 1, and x equals 3. Like I said, make it as easy as you can. Then you're going to plug this number, x equals negative 3, into the derivative, which can be either one of these, simplified version. And if your answer is negative, you're going to put negative here. If your answer is positive, you'll put positive here. So this one here, when we plug in a negative 3 into this equation, we should get a negative number. I don't care what the number is, just that it's negative. When we plug in negative 1 into the derivative, you should get a positive number. When we plug 1 into the derivative, we will get a negative number again. And when you plug 3 into the derivative, you will end up getting a positive number. So now what we have to do is decide what's going on here. We have a decreasing function in this interval, decreasing part of the function. This part is increasing, this part is decreasing, and this part is increasing. So to figure out where we have negative 2 is a critical number, 0 is a critical number, and 2 is a critical number. So to figure out where those things, I'm going to use the black there. So see, this is decreasing, and then, I'm going to use this one, sorry. This is decreasing, and then increasing. So this right here is going to be a minimum. So negative 2 is going to be a relative minimum. Okay? So negative 2 is going to be a relative minimum. We'll figure out the y value in a minute. Then this is going increasing, then decreasing. So 0 is going to be a relative maximum. Okay? And then we go decreasing like this to increasing again. So this 2 right here is going to be a minimum again. So we've got 2. And if you plug into the original equation, you plug negative 2 into the original equation, you're going to get 0. Same thing with 2. That is our point. Those are our two relative minimums. Those are valleys on our graph. And the maximum is going to be, when we plug in 0 for this, we end up getting actually the cube root of 16, okay, when you simplify it down. And that's all there is to it. So hopefully you got that, and you can try that third problem there on the back of your packet and see if you can do this on your own.